Hello friends and my dear students, I welcome you all to my channel. So this is part 2 video from the chapter of limits where I will discuss about some very obviously intuitive limiting values when particularly x is tending to 0 or infinity. This is a very this is a very mandatory thing that you must understand to solve while solving problems on limits. So this video is part of the playlist Problematic Mathematics for class 11 where I will be primarily discussing about the key concepts and formulas of all the chapters of Mathematics 11 focused towards solving problems that comes in the competitive examinations like JEE Mains, JEE Advanced or WBJEE. If you find this video beneficial, then please like it, share it with your friends, and if you want to further support me, then please subscribe to my channel and do not forget to press the bell icon so that you will be notified by my future videos. Okay, so I prepared my quick notes for all the very preliminary limiting values which are some of which will be intuitive. Okay, the first one is that when x is tending to 0 positive, that is when x is taking a value which is just a little more than 0, it is a positive value, then the 1 by x will tend to positive infinity, which is obvious. There is nothing much to understand in this. This thing in the limit form we say limit x tending to 0 positive, limiting value of 1 by x when x tends to 0 positive is infinity or positive infinity. Infinity means by default it means positive infinity. Okay, the second one is when x tends to 0 negative, which means implies 1 by x tends to minus infinity. That is when x is taking a value a little less than 0, that is x is a negative value but it's almost a 0 but negative, then 1 by x will tend to minus infinity. In the limit form we say limiting value of 1 by x when x tends to 0 negative is negative infinity. Okay, third one, when x is tending to either positive infinity or negative infinity, then 1 by x will always tend to 0. That is when x is extremely large. Now one thing, please note that infinity, when we say that x, any variable x is equal to infinity, this thing, I mean infinity is not a fixed it is not a fixed value. It is not a fixed value. It's an extremely large value, but it is not fixed. So x equals to infinity actually means that x is tending to infinity. These two are the same thing. Whenever you see if it is mentioned that x is equal to infinity, actually it means that x is tending towards infinity. Similarly, x is equal to minus infinity, it means x is tending to minus infinity. Okay. Now, so when x is tending to either positive infinity or negative infinity, then 1 by x will always tend to 0. In the limit form we say limiting value of 1 by x when x tends to positive or negative infinity is equal to 0. The first three are very obvious. There is nothing much to think about it. It's very obvious. Okay. The fourth one says consider a fixed real number a. A is a fixed real number. Obviously, it's a finite real number. Then, when a is greater than 1, then x tending to positive infinity will imply a to the power x will tend to positive infinity. In the limiting form, we say limiting value of a to the power x when x tends to positive infinity is equal to infinity when the finite fixed real value a is greater than 1 is greater than 1. Okay, and also the second part is that when x is tending to minus infinity, it implies that a to the power x will tend to 0. That is, when x is tending to minus infinity, it's an extremely large negative value, then a to the power x will be negative, so the power will be negative, so a to the power x will tend to 0. Or in the limiting form, we say limiting value of a to the power x when x tends to minus infinity is equal to 0 when, remember, that a is greater than 1. Now why is it that when a is greater than 1, limiting value of a to the power x is 0 when x tends to minus infinity? Now a, when x, I can say x tending to minus infinity, if when x is tending to minus infinity, okay, even though I think it is very obvious, but I am trying to explain why why is it so. So why is, okay, so limiting value of a to the power x when x is tending to minus infinity, I can equivalently write this to be equal to limiting value of x tending to, not x but let's say age. I'm doing a little bit of variable substitution. When x is tending to minus infinity, I can equivalently say that age tending to infinity and a to the power h. Limiting value of a to the power x tending to minus infinity can be alternatively written as limiting value of a to the power h, where h is tending towards infinity. Now we already know that sorry, a to the power not h but a to the power minus h. When h is tending to infinity, then definitely minus h will tend to minus infinity. So limiting value of a to the power x when x tending to minus infinity, I can equivalently write it as limiting value of a to the power minus h when h is tending to infinity. Now this is equal to it is becoming very congested. This is equal to limiting value of h tending to infinity 1 by a to the power h. Now a to the power h when h tends to infinity, we know already is infinity. So, and 1 by infinity is obviously will tend to 0. So we have this result. Okay. Now it the first two, these two was when a was greater than 1. Now if a is less than 1 but greater than equal to 0, then when x will tend to positive infinity, a to the power x will tend to 0. In the limiting form, limiting value of a to the power x when x tends to infinity is equal to 0 when a value of a lies between 0 when a value of a is less than 1 but greater than equal to 0. Similarly, when x is tending to minus infinity, then a to the power x will tends to positive infinity. You can verify this applying the same logic that I explained this on the left hand side. Okay, and the third one is that if x tends to 0, then a to the power x will tends to 1 when a is greater than 0. If the value of a is greater than 0, then if x tends to 0, it will imply a to the power x will tends to 1. Now remember, this a is greater than 0. A is greater than 0. It is some finite. It is some finite positive value. It is not like a greater than 0 does not imply that a tending to 0 positive. No, it's a relatively not as small as 0 positive. It is greater than 0, but it could be small value like 0.2, 0.3, 0.4. In that case, when x is tending to 0, then a to the power x will tend to 1, but a has to be a positive value. Okay. Now this should be point number 5. Okay, now comes some trigonometric limiting values. If x is tending to positive or negative infinity, then sin x will take values, the values of sin x will fluctuate between -1 and 1. Because we know that the for values of x from minus pi by 2 to pi by 2, the values sin x takes the value of -1 to 1, which is the range of the function sin x. Now, so when x is tending towards positive infinity, you know from the curve, from the graph of the sin x, from the graph of the function sin x, you can clearly understand that when x is tending to infinity, x can take, the infinity is not any fixed value. Infinity is not fixed value. I mean, it could be an infinity can be considered as like it could be considered a value like 2n pi, where n is a natural number, when n is a very very big natural number, 2n pi, in which case its value will be 0. And I can easily, so I hope you can understand that since the sine the graph of the sin x is something like this, at a very extreme large value of x, that is when x tending to positive infinity, that infinity could be any, I mean, let's say it could be that infinity value could be anywhere, can take any value, so that the value of the sin x is ranging from -1 to 1. It can span the complete cycle of the sin x. Similarly, on the left hand side also, if you go extreme to the extreme left, if you consider a very very negative value of x in terms of radian, it could be, let's say, let's say minus 2n pi, where n is a very very large natural number, then it will be 0. But if I go again 2n pi minus pi by 2, then it will be sine of minus pi by 2, which is 1. So you can understand that if you since the infinity is not a fixed value, I can consider any value, a very very large value in terms of pi, which will span, whose value will lie within the complete cycle of sin x. So in that case, its value can be anywhere from -1 to 1. So essentially, I think possibly I couldn't explain it properly, but the thing is that when x is tending to infinity, then if you know the graph of sin x, you will understand that the value of sin x could be anywhere between -1 to 1, considering what exact value of infinity you are considering. So in both ways, that is when x is tending to positive infinity or minus negative infinity, sin x will not, the value of sin x will fluctuate between -1 and 1, in which case we say that the limiting value of sin x does not exist when x is tending to positive infinity or negative infinity. A limiting value of an fx at x tends to a only exists when it takes a finite value, fixed finite real number. Same is the case when for cos x, when x is tending to positive infinity or negative infinity, the value of cos x will fluctuate again in the range of -1 to 1. So the limiting value of cos x when x is tending to positive or negative infinity does not exist. Again, the same is the case for tan x, but in case of tan x, when x is tending to positive infinity or negative infinity, the value of tan x will fluctuate between minus infinity and positive infinity. So, the limiting value of tan x also does not exist at x tends to positive infinity or x tending to negative infinity. Okay. Now, when x tends to 0 positive, that is x is a little more, x is positive and it is just a little more than 0, then sin x will tend to 0 positive, or the limiting value of sin x when x tending to 0 positive is equal to, we can say 0, but it is more appropriate to say 0 positive, that is a positive value, just a little more than 0. And when x tends to 0 negative, then this will imply the value of sin x will tend towards 0 negative, that is it will be just little less than 0. The value of the sin x will tend to a negative value, but that negative will be extremely small. So in the limiting form, we say limiting value of sin x when x tends to 0 negative is equal to 0 negative, which means that the limiting value is just little less than 0. When x tends to 0, then cos x tends to 1. That is, now when x tends to 0 implies cos x tends to 1. This actually means that when x tends to x tends to 0 positive, cos x tends to 1, as well as when x tends to 0 negative, cos x tends to 1. So limiting value of cos x at x tending to 0 is 1, which means that x tending to 0, remember that x tending to 0, when we say x tending to 0, it means that x could tend either from the right hand side, that is x tending to 0 positive, or it could be x tending to 0 negative. So when we say x tending to 0 implies cos x tending to 1, this means that x tending to 0 minus 0 negative implies cos x tends to 1, as well as x tending to 0 positive implies cos x tends to 1. Okay. When x tends to 0 positive, then tan x tends to 0 positive. That is, limiting value of tan x when x tends to 0 positive is 0 positive, and when x tends to 0 negative, then tan x tends to 0 negative. That is, limiting value of tan x when x tends to 0 negative is 0 negative, which means a value which is just little less than 0. It is negative, but very small value, very small negative value, which is basically 0 negative. Okay. 5 is, let's consider k to be a finite real constant. It's a constant, finite real constant. Then if when k is greater than 0, then x tending to 0 will imply x to the power k will be tending to 0. Now remember that x tending to 0 implies x to the power k tending to 0, means that both x tending to 0 positive will imply x to the power k tending to 0, as well as x tending to 0 negative will imply x to the power k tending to 0. So we say that limiting value of x to the power k when x tends to 0 is equal to 0 when the real constant k is greater than 0. K is greater than 0. Over here, I am wondering, x tending to 0 positive, will definitely imply x to the power k will tend to 0 when k is greater than 0. When k is greater than 0, this is fine, but what will be when x tending to 0 negative? X tending to 0 negative, will this imply that x to the power k will also tend to 0? So x is taking a value, a negative value. X is negative, but a very small negative value. A very small negative value. But a small negative value, but okay. So any negative value, a very small negative value, 0 negative means a very small negative value. So let's say it is minus 0.001. Now what is minus negative of 0.001? This whole raised to the power, let's say k is a finite real constant. Let's say k is k is, let's say, half. I mean, when the base is negative, in the exponential form, when the base is negative, then we do not have, then the power always has to be integral. Or the power always has to be integral. Okay, so I think I think when k is greater than 0, I should say that when x tending to 0 positive, I think this will be more appropriate. I mean, I'm not sure whether if x tending to 0 negative will imply x to the power k will tending to 0. I am a little doubtful about this, but definitely when x tending to 0 positive, this will imply x to the power k will tending to 0. Because when x is tending to 0 negative, then basically the value of x is a negative value, and in the exponential, then x to the power k, the base will be negative, and then k has to be integral. Now if k is integral, then possibly we can say it will tend to 0, but then what if k is not an integer? It will be a little problematic. So I think I think the correct result is that when for a finite constant real k, if k is greater than 0, then we will have x tending to 0 positive will imply x to the power k tending to 0. Okay, now when k is less than 0, when k is less than 0, I think here also we must have x to the power, when x is tending to 0 positive, it will imply x to the power k will tend to positive infinity, because we can say that so y, when k is less than 0, then y when x tending to 0 positive is implying x to the power k will tending to positive infinity, because k is less than 0. So we can say let k is negative, so let's say k is minus h, where h is greater than 0. Then x to the power k, then x to the power k will be x to the power minus h, which is 1 by x to the power h, 1 by x to the power h. And so when x will tend to 0, then x to the power h, where h is greater than 0, will tend to 0, and 1 by 0 will tend to infinity. So when k is less than 0, then x tending to 0 positive will imply x to the power k tending to positive infinity. Okay, now the last two are regarding the logarithmic function. So when x is tending to 0 positive, then it will imply log x will tend to minus infinity. Now why 0 positive? Because log x, by definition, log x has to be a positive number. For log x to be defined, x is always greater than 0. That is why we are consider that is why we will never have x. That is why the limiting value of log x does not exist when x is tending to 0 negative. So when x is tending to 0 positive, the log x value will tend to minus infinity. It will tend to minus infinity, or we say limiting value of log x when x tends to 0 positive is equal to minus infinity. Because if x is very very small, it means that we know that if log x is equal to m, this is nothing but e to the power m is equal to x. E to the power m is equal to x. Now, what value of m is a value which is greater than 1. So, what value of m will make x to be a very small? M has to be minus infinity. When m will tend to minus infinity, then only we will have x to be equal to 1 by e to the power infinity, which means e to the power infinity is infinity and 1 by infinity is 0. So, this thing you must be very clear about, that when x tending to 0 positive, then log x, the base is always obviously e, log ex will tend to minus infinity, and when x is tending to infinity, then log x will tend to also infinity. So, these are the basic preliminary limiting values which will be very extensively and rigorously used while you will solve the limiting problems on limits to understand the form. You know that there are various forms: 0 by 0, infinity by infinity, indeterminate forms, infinity, minus infinity, 1 to the power infinity, 0 to the power 0, infinity to the power 0. To understand those forms, all these preliminary limiting values you must very well understand. I don't know whether there are okay. Let's see now. When x tends to 0 positive, this will obviously imply root over x will tends to 0. Now again, limiting value of root x is not defined when x is tending to 0 negative, because the root function is always defined for positive value of x. So this we have this. Yeah, I think I will add this one only. Okay, now one thing I would like to say, that in all these preliminary or obviously intuitive limiting values, the variable we were always discussing whether x is the tending value of a variable x. Now all these results can be generalized. Instead of x, it could be fx. Now I will be using some notation in my future videos like this. What does this mean? Fx tending to 0. Fx tending to 0, this means that, let's say we are considering some limiting value of some function when x is tending to a, and we see that there is a function fx, so that we are having limit when limit x tending to a fx is equal to 0. This thing, that when x, the variable x is tending to a value a, then the limiting value of fx is equal to 0. This thing in short form we write as fx tending to 0. Now all these results can be generalized using fx tending to 0, or fx tending to infinity, or fx tending to 0 positive, fx tending to 0 negative, or fx tending to negative of infinity. For example, I can say that if now I will also use some notation like this: limiting value of e to the power fx, where fx is tending to infinity. When I write infinity, only infinity means obviously positive infinity. This will be equal to infinity. Now, what does this mean? That limiting value of e to the power fx when fx tending to infinity is equal to infinity. So this is the general form. This is the general form of when we say we usually see in the textbook that limiting value of e to the power x when x tending to infinity is equal to infinity. And we also see that limiting value of x tending to infinity e to the power minus x is equal to 0. So this thing can be generalized as limiting value of e to the power fx. So instead of only x could be a function of x, and when obviously any limiting problems, the variable x will tend to some value, will be tending to some value, let's say x tending to a. And if when x is tending to a, if fx is tending to infinity, then we say that fx tending to infinity, this will be equal to infinity. And the generalized form of this result is that limit fx tending to infinity e to the power minus fx is equal to 0. Also, let's say we will have limit 1 by fx, limiting value of 1 by fx when fx tending to 0 positive, this will be equal to positive infinity. I am just trying to introduce the general form, the general results. Instead of x, I am using fx. So this means that so if x is whatever value x is tending to, if when x is whatever value x is tending to, if for that value of x, if fx is tending to 0 positive, then the limiting value of 1 by fx will be obviously positive infinity. And we also in general we write the limiting value of 1 by fx when fx is tending to 0 negative, this will be equal to minus infinity. So this kind of notation I will use to explain various results in my future video. I just wanted to introduce them so that you will understand. I will end the video here. If this video was beneficial, then please like it, share it with your friends, and once again please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. If you have any question or any doubt regarding the concepts I am explaining or results I am discussing, then please feel free to let me know in the comment section. I will highly appreciate that, and I will do my best to address your query or to clarify your doubts. I have not yet decided what I will discuss in the next video. It could be probably I will discuss about the indeterminate forms. Indeterminate forms like the 0 by 0 form, infinity by infinity form, infinity minus infinity, 1 to the power infinity, 0 to the power 0, and 1 to the power infinity. I will discuss those thing in general, the very basics of the indeterminate forms, and then in the later future videos I will discuss in more details how do we solve problems on that deals with the exponential indeterminate forms. So those videos are coming soon. So please stay tuned. I'm ending the video here. Thanks for watching, and until the next video, take care and bye.